Good evening guys, Bagus to Mark C from BSME4. So this is my answer for number 2 that has a given which are pressure 1 is equal to 1 atmosphere. So you have to make this into a standard form, which is 101.325 kilopascal. Temperature 1, which is 60.3 degrees Celsius. So you have to make it also a standard form. So you have to add 273.15 to make it into Kelvin. So the answer is 333.45 Kelvin. RK is equal to 18. P3 is equal to 7,695 kilopascal. RC is equal to 1.5. Mass flow rate is equal to 1 kilogram per cycle, and the K is equal to 1.31. So for letter A, which is finding the clearance, you have to use this formula. RK is equal to 1 plus C over C. So you have to substitute all the data here, which are RK is equal to 18 is equal to 1 plus C over C. So C is equal to 18 is equal to 1 plus C over C. C is equal to 0.0588. So you have to multiply it by 100% to make it into a percentage. So the clearance is equal to 5.88%. So that's the clearance. So the next one is finding for the PVT of the cycle. So PVT. So from point 1, you will find the volume 1. So you will use this formula. P1 V1 is equal to MR T1. So you can derive this formula into V1 is equal to MR T1 over P1. So you also need to substitute all the data here. So 1 kilogram R, which is equal to 0.28708 kilopascal cubic meter per kilogram Kelvin, multiplied by the temperature 1, which is 333.45 Kelvin over 101.325 kilopascal. So we can answer, the answer that we get from here is 1 over 0 times 0.28708 times 333.45 over 101.325 is equal to 0.9448 cubic meter. So the volume 1 is equal to 0.9448. So next one is finding the V2, P2, and T2. So we can get this from point 2 of the cycle. So first we use this equation. RK is equal to V1 over V2, and from this we can use this V1. V2 is equal to V1 over RK. So we substitute the data here, 0.9448 over 18. So the answer that we get from here is 0. The V2 is equal to 0.0525 cubic meter. So the V2 is equal to 0.0525 cubic meter. So the next one that we are going to find is the pressure 2. So we will use this equation. P2 over P1 is equal to RK raised to K. But V1 over V2 is equal to RK. So we will use this equation. P2 over P1 is equal to RK over K. So from this, we will use this. P2 is equal to P1 RK raised to K. And we substitute all the data again here. P2 is equal to 101.325 kilopascal times 18 raised to 1.31. So the answer that we get from here is 101.325 times 18 raised to 1.31 is equal to, so pressure 2 is equal to 4,468.107 kilopascal. So that is the pressure 2. So the next one is finding the temperature 2. We use this formula in finding the temperature 2. V1 over V2 K minus 1. But V1 over V2 is equal to RK. So we use this formula. T2 over T1 is equal to RK raised to K minus 1. So from this equation, T2 is equal to T1 RK K minus 1. So T2, we substitute the data here. T1, which is equal to 333.45 Kelvin times 18 raised to 1.31 minus 1. So the answer that we will get from here is 333.45 times 18 raised to 1.31 minus 1 is equal to 816.893. Kelvin. So that is the temperature 2. So the next one is finding the velocity, the volume 3, the temperature 3, the volume 3, and the temperature 3. So at point 3, since V3 is equal to V2, it is also the same as the volume 2, which is equal to 0.0525 cubic meter. So that is V3. So for finding the T3, we use this formula. T3 over T2 is equal to P3 over P2. So from this formula, we will get this formula. T3 is equal to T2 times P3 over P2. So all we need is substitute all the data here, which is T3 is equal to 816.893 Kelvin multiplied by the pressure 3 which is 7695 kilopascal, over the pressure 2, which is 4468.107 kilopascal. So from this equation, we get the temperature 3. 16.893 multiplied by 7695 over 4468.107 is equal to 1406.858 Kelvin. So the temperature 3 is 1406.858 Kelvin. So the next one that we are going to find is the volume 4 and the temperature 4. So at point 4, we can get this data. So we use this formula, T4 over T3 is equal to V4 over V3. But RC is equal to V4 over V3. So V4 is equal to RC V3. So we can get the value of V4 from this formula. So V4, we substitute all the data from this formula. V4 is equal to 0.0525 cubic meter multiplied by 1.5. So the answer that we get from here, 0.0525 times 1.5. V4 is equal to 0.07875 cubic meter. So there is the volume 4. So the next one is finding for the temperature 4. So we will use this formula in finding T4. T4 is equal to T3 RC. So T3, which is 1406.858 Kelvin, times the RC, which is 1.5. We will find the value of T4, which is 1406.858 multiplied by 1.5. The value of T4 is equal to 2110.287 Kelvin. So that is the value of T4. So next one is finding for the temperature 5 and T5. So at point 5, we will get these two data. So for finding the temperature 5, we use this formula, T5 over T4 is equal to V4 over V5 raised to K minus 1. So this is also equal to RC K minus 1 over RK K minus 1. So from this formula, we will get T5 is equal to T4 multiplied by RC K minus 1 over RK raised to K minus 1. So we substitute the data here, which is T4 equal to 2110.287 Kelvin multiplied by RC, which is 1.5 raised to 1.31 minus 1 over 18 raised to 1.31 minus 1. So from this, we can compute the answer. 1.5 raised to 1.31 minus 1 over 18 raised to 1.31 minus 1 So the answer that we get is 976.776 Kelvin. So that is the temperature 976.776. So next one is finding the pressure 5. So in finding the pressure 5, we use this formula. P5 over P1 is equal to temperature 5 over temperature 1. So we can derive the formula into this. P1 times T5 over T1. So we can now solve the P5, which is P5 is equal to, let's substitute all the data here, 101.325 kilopascal. T5, which is 976.776 Kelvin over temperature 1, which is 333.45 Kelvin. So P5 is equal to 976.776 over 333.45. So the answer that we got is 296.812. So that is the pressure 5, which is 296.812. So the next one is finding for the work. So see, which is finding for work, we use this formula. Work is equal to heat added minus heat rejected. So in heat added, you will need to find both the formula of this. So in heat added, the formula is equal to mCV multiplied by T3 minus T2 plus mCP multiplied by T4 minus T3. So you will need to find the value of CV and CP. The formula of CV is equal to R over K minus 1. So R is equal to 0.28708 over 1.31 minus 1. So the answer that we got from here is 0.28708 over 1.31 minus 1 is equal to 0.9261 kilojoule per kilogram Kelvin. Next is finding the CP, which is CP is equal to KR over K minus 1. So it is equal to 1.31 times 0.28708 over 1.31 minus 1. So the value that we get from here is 1.2131. CP is equal to 1.2131 kilojoule kilogram Kelvin. So we can now solve for the heat added and heat rejected. So QA is equal to mass is equal to 1 kilogram, CV, which is 0.9261 multiplied by the T3, which is equal to 1406.858 minus 816, which is the T1.893, plus the mass 1 kilogram, then the CP 1.2131 multiplied by the temperature 4, which is 2110.287 minus 1406.858. So the heat added that we can get from here is 0.9261 times 1406.858 minus 816.893 plus 1 kilogram times 1.2131 times 2110.287 minus 1406.858 is equal to 1399.696 kilojoule. So this is the heat added. Now we solve the heat rejected. So heat rejected is equal to mcv T1 minus T5. So we substitute all the data here, which is 1 kilogram times 0.9261 T1, which is 333.45 minus the T5, which is 976.776. There. So the answer that we get from the heat rejected is 1 kilogram times 0.9261 times 333.45 minus 976.776 is equal to negative 595. QR is equal to negative 595.784 kilojoule. So we can now get the work is equal to QA, which is 1399.696 kilojoule minus the QR, which is 595.784 kilojoule. So the answer that we get from work is 803.912. So there, that's the work. So the next one is finding the efficiency. So the efficiency is equal to work over heat added. So the work is equal to 803.912 over the heat added is equal to 1399.696. So the efficiency that we can get here is equal to 803.912 over 1399.696 is equal to 0.5743, and we can multiply it by 100% to make it a percentage. So the efficiency is equal to 57.43%. That's the efficiency, 57.43%. So the last one that we can find here is the mean pressure. So the mean pressure formula is work over V1 minus V2. So work is equal to 803.912 over the V1, which is 0.9448 minus 0.0525, which is the volume 2. So the mean pressure, kilojoule over cubic meter. So we can make it into kilopascal by multiplying kilopascal cubic meter by kilojoule. So there, 803.912 over 0.9448 minus 0.0525. So the answer that we got is 900.944 kilopascal. So that's the mean pressure